All right, cool. Get my phone going. Good afternoon. So, yeah, a few things before we get started. All right, thanks, Carlos. Appreciate it. All right, woo, I could submit my travel reimbursement. Um, so yeah, so a few things as we're getting started. So, there's a joke that floats around the internet. I don't know, it's been around for a while, like me. And there's this guy, I'm assuming he's Canadian, older man. And as he's saying, he says, well, there was a commercial. Well, this is the commercial I'm explaining, sorry. And he goes, yeah, I don't drink beer often, but when I do, it's Heineken. Like that's the top, beer or whatever. And so then the joke that was going around on that is, I don't take my recyclables out often, but when I do, I look like a raging alcoholic. Um, and so I was thinking about that because I looked back. So this is our third presentation for OWEB conferences where I've talked about stream temperature. So this is probably the last time, no more. And I was looking back at the old presentations, and I'm a data junkie, and there was a lot of stuff in there, and statistics and data and various things I was talking about, and I felt really bad. So I'm like, oh my gosh. All right. So yeah, so I thought this time I'm going to switch it up a bit and have a lot more pictures. This is more of a picture story. And yeah, there'll be a little bit of data in there, and of course, but a lot of summaries. And then I thought that this, hopefully could lead to so a fair amount of discussion. So anyway, for you data junkies out there, we could talk another time, but this is what I have in mind. So Carlos and I, so first of all, let me see which one moves it. How about that one? Enter. How about spacebar? Oh, how about?
Try hitting the escape key.
I know, right? Well, so this is the PC is. I know, right? Okay, well, oh, the escape doesn't even work. All right, well, anyway, I'll let you play. So what we were doing, so Carlos and I'll step over here. So Carlos and I have been working on some long-term research projects. And by long-term, we are committed to 10 years as long as the funding holds out, and we're about there, about a year away. And so we've been doing a variety of projects, and one of these was in Western Oregon, Willamette Valley, looking at the impacts of various kind of ag practices on water quality. And then I took part of that and wanted to focus on temperature. And then we've got obviously other locations around the state, but we got into so yeah, it's just not going forward, and I keep hitting all the various buttons. So yeah, of course. Thanks. Thanks. You mean you just press it? Okay. Woo. All right. So all right. So yeah, so we have these two watersheds, and the ones in Eastern Oregon that I've been doing on stream temperature as well. And so I thought, oh, it's been pretty interesting that I've taken this frame of reference that I've done most of my work in Western Oregon and then transfer that to Eastern Oregon and like kind of see if it fits. And so that's what I'm talking about. So the topics that I'm covering is we'll talk about watershed characteristics of these two watersheds, which stream environment relationships are impacting heating and cooling that we've been finding. How do stream temperatures vary in the downstream direction? So most of our monitoring sites are along the main stem going down. We have some in tributaries close to the mouth, but essentially it's kind of looking at this change as you go in the downstream direction, or longitudinal profile, as I might say. And then also, I mean, ultimately, how do these results inform riparian stream restoration priorities? I mean, how do we really like take our data and, what is this telling us? How do we get some use out of that, as opposed to just saying whether we're above or below the standards? Here you go, DEQ. All right. And I say that beyond the obvious because, we know which systems we would expect there to be that are capable of providing trees, and they have riparian zones that would have forested. areas as opposed to others that may not. And so when there's expected that it can hold trees and there's not, we put trees, right? So that's pretty straightforward. So what I'm interested in is really those locations in which you're getting cooling where you wouldn't expect, or you're getting other factors that are in addition to solar radiation, which of course solar radiation is the driver, but when is it that shade may be the dominant factor or there's other components that are dominant? Because then you really get at, okay, so how do we really prioritize these other places that have varying degrees of shade and using our temperature data? And the fish is on there, it's cutthroat trout, because that's been my focus and of why I've been doing this work, because it relates to that. Okay, so oh, and I did want to say, so the things I say may not represent the views of my co-author because he hasn't reviewed this yet. So or the administration at OSU because some of this is OSU property. So anyway, with that being said, so Oak Creek. So this is Western Oregon, Benton County. So it's on the lee side of the Coast Range. So it's part of the Marys River, and Marys River has some tributaries to it that are more kind of rain on snow. So it gets more snow in the higher elevations and rain on snow that's dominating. This one is more dry. So I mean, more on the warmer side. It does get some snow up there, but it's at a much less amount. So anyway, so it's a little bit more of the warmer type of watersheds that you would expect as compared to some of the other Marys. So Oak Creek, and so a few things here, all of these circles, there's our various temperature data stations, stream temperature. And then also we have some that are air temperature in there. We put in the riparian zones. And then we have a couple of weather stations, one at kind of a moderate elevation and one at the lower elevation. Yeah, so that's what's showing there. And then, so what are some of these descriptors that we normally think of in terms of watersheds, and kind of hopefully this resonates with at least a few of the data junkies here. So first of all, this is about 13 square miles of a watershed, a little less than a 12-digit HUC. So in my mind, it's like if you have this kind of perfect planning size, if there is one, I really like that 12-digit HUC or even slightly smaller, because in my mind, it's big enough to where you're covering some area and able to prioritize and kind of spread out your assessments and monitoring and programs, but it's also not crazy big so that you feel just too spread out. So that's the size. And the stream orders, Strahler stream order is fourth order. It gets to be fourth order about the middle of it. So if you see those it has like two main branches. You have the main stem Oak Creek and then the other one, Alder Creek, that come together. So where they come together right here in this clump of circles and names and stuff is where it becomes the fourth field. And then from there down. So the length of the main stem from the watershed divide, if you continue that main stem up to the divide, is about 7.5 miles. And then the range and elevation down in Corvallis is about 210 elevation. So that's the lower part. The mouth of Oak Creek goes into Marys River, just slightly upstream from Willamette. And city of Corvallis down there is the city that we're looking at. So the range and elevation is about 210 feet elevation at the base, on up to 2,200 in the high part there. So as you can see here is that most of the creek, most of the main stem is a south aspect, a southeast aspect. So a fair amount of it is obviously getting, the most amount of sun hitting that. And then in terms of precipitation, roughly on the lower end, it's about 3.1 feet. So not quite 40 inches. And then on up to 8.2 feet up in the high elevation. So that's the range of precipitation. And as I mentioned, it's mostly rain, although there's a little bit of snow in the wintertime, but but it doesn't stick around long. And then the other component of this that is important is that there's in the upper part, so this watershed here, can you see my cursor on there? Yeah, I guess sort of. So right about here where it really changes from forested to ag. So in this section, and then a little bit lower, this area is kind of a divide. That's a geologic divide. And the upper part has fairly shallow depth to bedrock in the upper part. I mean, in some areas you may be digging down like 5-8 feet or so when you're hitting that fractured basalt is the main thing. And then at the lower end, that's more like Willamette Valley, typical, much deeper soils in that zone. And so it also gives a really different hydrology break within this watershed. And then the land uses here are three different types. So in a lot of ways, it represents kind of many different watersheds around the state. So the upper part is forested. Let's see if I have, woo, all right. So the upper part is forested. That's anything that is not surrounded by a color there. So ag and rural residential are the orange and red. So you have these little pockets of agriculture. The ag and rural residential is in this middle part. That's the OSU Sheep Center that's managed there, as well as some rural residential larger lots. And then in this lower section, orange, that's the other, the OSU Dairy and Poultry Center, the other kind of centers around there. And that's more of a larger commercial ag component. And then the urban is purple. So that's OSU campus as well as urban residential there. So the main stem flows through all three of these different land uses. The other thing about Oak Creek is that for the most part, it's got a forested riparian zone. I mean, we could question about how much is really forested versus not, but I'd say like the minimum width that I've seen as far as setback is about 15 feet. And so there's some trees in every riparian zone. So the worst of it is a few areas where the trees are kind of minimal and there's a lot of blackberry and reed canary grass, just like many other streams around the valley. But then in the best of times, in the best of it, there's well over 100-foot forested riparian buffer, especially up in the forest. And then also in this lower urban section down through Corvallis, that area is pretty wide, everything from 35 feet on up to spots that are over 100 and forested there. The riparian zones are mostly hardwoods, so a lot of big leaf maple, as well as alder and willows and ash, the lovely ash. Yeah, that's going to be some big changes. So ash kind of sprinkled throughout, at least in the mid and lower sections. So anyway, fairly well forested. Okay, so Fish Creek. So this is the east side, right? Far east side. You see, I didn't have enough time in GIS expertise to do a new map. So it's pointing to the area where that watershed is. So it's a part of the tributary. So it's Willow Creek that flows into Mount Hur River. It's pretty close to the same latitude. So really similar in terms of solar, at least solar angle and everything. And so at Fish Creek, same thing as before, although this is a little bit cleaner. So the circles are stream temperature monitoring stations. The triangles are air temperature, so riparian air. And then we have a weather station at the very top, close to the divide, and then also at the bottom. Those are the squares. I don't know what color that is. I only know 8, and that's not one of them, but kind of bluish maybe. So yeah, and so there's a lot of similarities with Fish Creek and Oak Creek. So one, pretty similar size. It's a little bit smaller than Fish Creek is a little smaller than Oak Creek. It is the same stream order, so a fourth order that also picks up its fourth order roughly kind of around that midway point. There's 2 main tribs that is what we were monitoring. Fish Creek is the main stem, and then the other one we've collected a lot of data on is Deer Creek. It's got a little bit shorter of a main stem length, so 5.9, so a little bit less than Oak Creek. The elevation, way different, right? So this is range country, livestock grazing throughout. So the upper range is the peak here, 6,400 foot elevation. So it's snow. I mean, it's a snow range, as well as sagebrush step up there. And then down at the lower end is 3,900 feet. And so we're just getting down into the valley, where, then it goes on for miles and miles. But you'll see a little more in the pictures. Similar aspect, kind of a southeast aspect and similar latitude. So, at least the sun angles are pretty similar here. So precipitation, way different, right? So this is more 1 to 2 foot of precipitation that's predominantly as snow. But then it also gets these occasional thunderstorms, particularly in the summer. And so you could get doused with an inch or so and under 24 hours. So definitely different hydrology. Similarly in bedrock, I mean, a different structure, but similarly, the upper part is a shallow depth to bedrock in the upper portions. And then on this one, the break in geology, the major break is kind of down here at this station before the last one. So it goes from kind of that geology to more of an open valley floor at that point, down to the last few stations down there. Incidentally, we have a few reaches that we studied in more intense detail, which I'm getting some information out of, but I'm not sharing all of those details. But we have a few study reaches, just like we did in Oak Creek, that we get a lot more in depth. Oh, so I'm sorry. So I was going to say that, yeah. So in addition to the shallow depth, in the lower valley being deeper, there's a lot of springs, particularly in the upper. So the characteristics of the site, that really kind of changes a lot of things. But so they're kind of scattered around, more so in the upper part than in the middle, and then down the lower is pretty minimal. And in the very lower section, down in this valley, we have a well down there, and we've seen that there is some losing flow at that one. It's not like, draining out the bathtub or anything like that, but it is slightly lower. So in other words, it's not feeding it. So in late summer, being lower, it's not benefiting from the groundwater down there. Okay, so then in terms of forest types, land use types, this upper part is a sagebrush steppe with a little bit of juniper. Juniper is basically, you say a little bit of juniper for everything because it's scattered throughout. So a sagebrush steppe in the top with some juniper. Then in the middle is more of a mixed conifer, predominantly pine, but there's some Doug fir in there, and there's some juniper, of course. And then in the riparian zone, it's got a few more hardwoods, some quaking aspen, some cottonwoods, as well as willow and alder. And then in the lower part, goes back into sagebrush steppe again, and with the kind of the forested part is just right along the stream. So you have the sagebrush steppe with juniper. A lot of it's been removed through some restoration improvement type practices. But you do have some trees around the stream. So let's see. Oh, and then of course for land use, so it's pretty limited to cow-calf grazing. And essentially, they basically move them around from lower to upper based on season and moisture and feed that's available. So starting out in the lower elevations and working their way up until it becomes too dry, and then they're kicked off to the irrigated pastures and other things there. So it's and then also in the mixed conifer, they are growing that for timber. They've done some harvesting there. So this is a private ranch. But anyway, livestock grazing is the main thing. There is a large elk herd, which is pretty amazing, over 200. We know that because that's about how much we could count. And then it's like, it's over 200. So then it's pretty amazing. For better or for worse, and not there all the time, right? And then there's also, in terms of management, there's no riparian pasture fencing. These are pretty big units. And then the watering is in developed springs and in the creeks. So there's not protections along the riparian zone or anything like that. So hydrology. What are some differences here? So going back to Oak Creek first. So Oak Creek, this is now this is stream height, but this is a gauge station we have on the lower main stem, and so it's gauge height. But what I'm trying to show here is how flashy it is. So for us coastal folks and valley folks, yep, used to seeing that, right? So precipitation throughout the winter time, and then as you're getting in that spring, you're getting much less, and then it just slowly drains until we're back in the fall and hopefully start up again. And then there's occasionally some rainfall events that are that late spring and summer. You have a few in there. And then with this also, there's irrigation on this stream. So right above where the gauge is, there's irrigation. OSU has an irrigation area there. So a couple of things, as I mentioned, it's more gaining in the upper watershed where groundwater is feeding it. And then in the lower part, it's more neutral to kind of low gain. It's kind of like coming back and forth depending on where you are. But essentially in both of these watersheds from about the midway point down in the summertime, there's no other trips. So you have this long, if you're thinking in terms of stream temperature, which I will get back to eventually, you have the influence on stream temperature. That section then really becomes part of the watershed and surrounding areas and really influenced because it's been there flowing down. There's no big tributaries coming into it in both watersheds. Okay, so imagine, and maybe you've seen this, hopefully you've seen this. So when you go out to do stream temperature monitoring in the summertime, essentially in our western streams, there's this little small flow and a big, huge channel. And so that's Oak Creek as well. It's built by all of these high flashy dynamic flows. I have some high flows here in Oak Creek that we measured a couple 85 and 64 CFS, or a couple of those that are not the peak, but pretty high. And then the low flow being down at that 0.5, maybe a little less than there at times in the low summer. But anyway, so you have this summertime flow that is pretty small, and then this big channel that it's kind of moving through. And I think that's much more common in Western streams. I'd like to hear if you found that. So there's also deep pools. So this, and I'm talking more of the mid to lower range, you have all of this wintertime flow that's created these deep pools. And so in the summer, you have deep pool and then a little trickle, and a deep pool and a little trickle as it moves down. And so that really plays into the temperature. So here's a little bit of shocker, but all of the different components, sort of some reminders of what influences stream temperature. So this is Oak Creek main stem looking downstream, and we have the sunlight coming in from the left. And so these are, so essentially you have incoming solar radiation, right? So that's obviously the big driver, that's the big heat input. But there's a lot of other factors that go along with this. So obviously shade. So shade being how much it can block on solar radiation. But then also we look at forested riparian buffer width, what's growing in there, as well as how wide that is and how tall it is, and how much that is factoring into the shade components. But stream bank height is actually a big factor when you have such large stream that with this large active channel characteristics in this little small stream in there. So stream bank height in the summer, wetted width and depth is really big. So shallow widths and depths for the most part. Okay, so keep those factors in mind. So here are some pictures of what Oak Creek looks like in the various parts. So up in the upper section in the forested area, as I mentioned, the riparian area is forested. And when you look at DEQ's shade analysis in the forested section, because they're looking top down from satellite, from imagery, this is all really high in the 90% shade. And whereas whenever I'm crawling in there and I have this little canopy imager that's basically a fisheye lens that's taking pictures, then I'm saying, okay, so what's closest to the stream? And my view is kind of stream up. And so what I found is that in some cases, like this middle picture, yeah, there's a lot of vegetation. I mean, it's crappy to walk in, right? You're kind of crawling around and getting through there. So that's really high. But in a lot of places, it's a little bit harder to. This one on the right, maybe you can see a little bit more there, that you have a taller upper canopy, but when you don't have a lot of the other multi layers of canopy, there is quite a bit of reflected light and other light that's getting in there. That is significant. Yeah, so you have upper forested, but it's pockets here and there of how much of the underbrush and shrubs and smaller trees are actually kind of hanging over and shading it. Yeah, these are just canopy closure numbers. But that's fine. So that's one set of factors. And then the other set of factors is what I was mentioning in terms of pools. So this is in the lower main stem to kind of exaggerate the point, because I saw this in other areas too. But anytime there's some big piece of large wood and roots or something that's there, you have a pool that's around there, and you have this depth and a lot more variation in stream temperature through there, as well as the big sediment piles that the water is moving through, right? So as we've learned, right, these are things that we've talked about, is this mixing and cool water mixing as the water moves through there. But the variety of habitat or variety of pools and riffles and gravels plays a big part in temperatures. Now, I'm not seeing that this makes a big change in the overall average temperature. And there's been some papers saying that all of this large wood and things in there hasn't been that much documented decrease in temperature due to large wood and so forth. However, I don't think that should really be the focus, because more importantly, it's the variety, it's the diversity of the different temperatures that you have that's important for the habitat. And so a couple of other, this beaver pond is more in the mid-range that's adding, as well as some deep scour. So anytime you have stabilized banks in which that large flows can dig out, then that's a bonus. And then also, I mentioned kind of this wetted width and depth ratio. So in general, width and depth increase as you move down valley. But it varies greatly through the reaches and through areas, primarily again, large wood, whereas there stable banks and high flows and all of these different components that add to it. And so you could have beautiful forested areas that are really wide and shallow and really increasing in heat. Sorry, that was a little bit too quick. And then you have other places where it's deeper and you're having this little bit of cool water that's coming into the edges of the pools and more area there. So again, lots of diversity. Okay. So one piece of data. So this is common data that you guys gather, although you probably didn't make it look like this. It's a little weird. So what I did was I took our years of data. So this is based on 6 years. And one of the analysis I did was just look at the 7-day average of the daily max, 7-day average of daily max, the DEQ, this is their criteria. And so what this is doing is, like, every year there's a range in what that highest is. And so I just averaged them. So each of these dots is based on the location in the longitudinal profile. The green on top, those are the max. And the blue, which I found is kind of interesting, is like, what is that minimum? So it's the associated minimum with the max. And so what we're seeing is, as it starts out in the upper part, that it's perennial. All of these are perennial sites. We have cool, but it's already at that like 16. I guess I was expecting it to be a little bit lower, but so 16. But then you have this huge jump from 16 on up to 19, all within the upper forest. So that's stream water 2 by that point. So you have this big increase, even though it's fully forested. So obviously stream is smaller, it's more affected by solar radiation, but it's more affected by a little bits of everything. But I was surprised that we had that jump. And I think most of that is due that even though it appears to have cover, it really, there's a lot of places to where it doesn't have much of the other layers of riparian zone and cover in there, or the large wood and the other factors that help. Then we have decrease where it cools from this warmer part and cools. And what happens through there is that there's much more of a gaining reach and there's a little bit more complexity in the floodplain. And so it's getting a little bit larger, but it has much more groundwater influence and change through that section. So then we're into the OSU parks. So this is increasing back up. We have a riparian zone that's a pretty good setback for most of it. And it has trees in there, but also has a lot of blackberry, a lot of reed canary grass. And so while it's a big buffer, it's the shade, it doesn't have the big high shade. It has a lot of the lower shade to it. And so the other big increase, and this is actually the steepest. So I was looking at where does it increase temperature the most in a particular area. And one of those is the irrigation pond, right? That's okay. That's one of those no-brainers. Not a whole lot of trees, irrigation pond, and the top part of the water spills over. So the hottest part ends up going downstream. So that's a major bummer, but it's not something that's like super surprise. But you still see a slight bit of heating from there down due to some of the openness. We got a much bigger channel in some exposed areas as well as shaded. But the other thing is that how much it decreases towards the end. So as it hits through OSU ag and then starts to go into the urban, you have multiple stations that big high banks, it's pretty entrenched in that area as insides down. So you have big banks that are providing shade as well as the riparian zone, and you're also getting down into some of that groundwater through there. So I was really surprised at how much cooling would be that far down. That's usually, you don't see that as much in papers and research. So the summary here for Oak Creek is you have overstory tree shade. That's just one component. So think about these in terms of layers. The smaller trees, large shrubs, large wood, and tall overhanging banks all contribute to cover or to shade or to protection, and they're all important, but just in different areas. And then in terms of pools, large wood, beaver ponds, scour when they're stable banks, all of these with that large wintertime flows really help create that. And then also there are cool tributaries. So we were seeing whether the tributary is surface water flowing or intermittent, there's still cooling that's coming in subsurface through those. So we've seen that, and then also some groundwater seeps that are keeping some of it from getting as warm probably as it could. Okay, so Oak Creek, that's west side. Now let's hop over to the east side and compare with all of those components in mind. What does that look like in terms of Fish Creek? So first, I want to start off with the precipitation. So as I mentioned, this is much more snow dominated. So this is actually flows, not just height. We have three different flumes. One is, so this is the first one is the lower one down. And you can see how you have usually like one big peak or maybe two peaks, and then it's relatively smooth. It's not as flashy as precipitation dominated, but you do see some flows in there. And then of course, obviously the really low summertime. The second one is in the mid-range. And so kind of the middle of the watershed, similar look. And then this far one is in the upper part, one of our another study reach. That is the smallest of any of them. Still getting pretty good flow there in the wintertime, 1.25 CFS for at least that size. But of course, summer, it goes down. So anyway, that's, and the precipitation graph, that may fool you a little bit. It looks more flashy than it really is because that's the water dripping to the tipping bucket. So anyways, it's just hard to show that type of precipitation. So the stream characteristics. So related to flows, so snowmelt driven, it's much more steady. And then you do have these thunderstorm flashes, which do change channel, a lot of sediment movement. But for the most part, you don't have this big, huge channel that's been scoured and created, and then a little small flow. It looks much more, the flow always seems to be roughly within that channel. It's not a big change. By the way, this is one of our flumes at the lower end measuring flow. So the low flows go an extended period. You have it starting in, say, June, July, all the way through October, so a longer low flow period. In the upper part, as I mentioned, it's more gaining from groundwater and losing in the lower part. Let's see. So in this watershed, the groundwater and springs, they're kind of popping out all over and play a much bigger role in terms of hydrology. As well as there's places where a lot of it just goes subsurface. So you have this big buildup of gravel and soil and things, and that's helping obviously cool it. Hyporheic exchange, there's a lot more movement of gravels and things, so a lot more water just kind of going through big gravel piles and areas as opposed to, more over it. And then the topography plays a big part here. It's just a lot of bigger mountainous areas. So summer, as mentioned, small flow, deep pools, and so again, so it's some similar things, small flow and still kind of a larger channel, but not created quite the same. And then deep pools and cover still having large impacts. So whoops, this is a funky thing. So, okay, so on a tour here from the upper part, so the headwaters are all these kind of springs, and then looking downstream, well, first on the left is the sagebrush steppe juniper area. And then from the spring, that's upper right, where it's coming out of the rocks, then looking downstream, this is a bit of the stream, but it created watering holes from the springs that are there for access. Pretty lush in that late spring, early June timeframe. And I put dates on here because it really makes a difference in how things look. So moving down a little bit further in that mixed conifer area, you get a feel for, so this is all August, so it's later summer where the green has a lot of water, but then if it's not water, it's brown, right? And so you get a feel for how much more sunlight, and it's not as obviously the carrying capacity in terms of large trees and overall vegetation is not like Western Oregon, but it still has capacity for some overhead as well as some understory there. And one of these pictures I'm showing a spring where the springs coming in as again makes a big difference. So in the mid part of the mixed conifer, another spot just a little further down, both canopy potential. So again, it has potential of having tall kind of overhead shade as well as the multiple layers in there. Whether it does or not depends a lot more on management. And then the temps are variable by topography plays a big role, obviously canopy, but springs play much more higher in this hyporheic exchange, and gravel and subsurface are big. This the one in the middle is and they have some roads right at historic roads, but that's mainly to show topography and how much topography influences that cover. Okay, and then down in the very low. So now we're getting into the valley at the very last section there. So the one on the left, so it has this riparian zone that's predominantly willows and some alders and a couple of cottonwoods, but you have this kind of small area there. And in June, it's still really lush, right? So it's green. They're grazing that lower portion, and then the cows will be moved up. But you can kind of see where in this upper right, where it gets later summer, it's essentially the stream green part, and then the rest is pretty dry. Lots of varied conditions due to grazing and just kind of changes within the system. So you don't have this like consistent blanket of overstory trees. And then this middle picture is our station there, giving you an idea of some of that variability. So again, temps variable based on canopy is big. So this is also the bank heights, and then pool depths. Any place where it can have it doesn't have the big monster wood, but any place where it can dig out and create pools. And then of course that hyporheic exchange is important. This graph I'm just showing like before, but I'm just showing you the 7-day average of daily max. In these, the orange points are the main stem, and the blue are Deer Creek, a little smaller. And so you see the range. So the warmest is almost at 30, so 30 degrees Celsius. And it also hits above 18, fairly far up there in the between station 3 and 4. So again, what's causing these big increases? Where are the steepest changes? So in the upper portion, the big steepest changes, there's not a whole lot of overstory potential for shade. So it kind of depends on the stream and how much springs are there and just how kind of overall exposed it is due to that environment. And so, yeah, and of course it's small flow. So really, really reactive in there. But then you have places where it really cools off, and that's showing you. So those are the springs and going subsurface whenever those show up. So you see that big influence there. In these other components, as we move down in the mixed conifer, so then that's increasing primarily due to more shade and some of the just kind of the overall factors there affecting the warming, kind of more of what you would expect to see in that type of environment, as well as a lower section down there where it really opens up from kind of mountainous topography helping, and then it kind of opens up to the valley. It gains a lot of heat there because you lose all that extra topography and other subsurface flow that's helping. So we have these two sections or several sections that are increasing, which is not too much of a surprise, right? But there's also decreasing. So again, there's this part where that arrow is a little bit off, but it goes from trying to show from here's FC8 at the midway point, which is under 16 degrees Celsius. So midway of the watershed and dropping back down, that's pretty considerable. But then it pops back up through that section through some warming there. I'm sorry. Scratch that. I knew something was weird whenever I was saying that. I was like, wait a minute. So these are minimums. So what I'm showing here, sorry. So this is the midpoint. I thought as soon as I said 16, I said, that's weird. I don't remember that. So 24 degrees, little difference, right? So the max, so what's happening here is it's heating up. And then in this mid-range, we're up in the 22 to 26 Celsius. So it's warm. But what happens is it goes through this big topographic shading as well as some springs in there. And so it cools from that 25, 26 down to the 22 level. So that was pretty significant there in that range. And then of course increasing again, as I mentioned before, to the openness. And then the last thing, which is again is not as common, or at least as reported, is a cooling down in the lower section, even though there's not a big change in terms of canopy cover or whatever. So it's pretty consistent, but you do have spots that do cool, and I seems like it's more due to the mixing of that, the hyperbaric exchange and mixing. So anyway, so summary here, say in the east side, so tall tree shade, again, it's not the only thing, but then also there's not the carrying capacity with that amount of precipitation that you would expect for cover. So you Eastern Oregon folks, yeah, of course, that seems, but for the Western folks, things are different, right? You just can't expect the same amount. So that makes all these other factors really important. So smaller trees, large shrubs, wood jams, overhanging banks, topography, all these components that can contribute to that make a huge difference in the temperature. And then the other component, as far as anytime there's deeper pools, habitat, so wood complexes, beaver ponds, scour and stable banks, things that were commonly identified. And then lastly, much more of identifying where the groundwater seeps are and subsurface flows and hyporheic exchange. So I guess, so in summary to all of this, for one, I'm getting a little bit more into wildlife now from being out there in Eastern Oregon. But no, so I guess whenever I set out on this, the goal was really, there's some things that related to solar radiation that we know. And we tend to focus so much on vegetative shade as the priority, and then looking at our temperatures in terms of the standards. But yet there's so much more information that we can gather from observing and being out at these places, and even doing kind of this approach. Of course, I like it because that's what we did, but the topographic, from headwaters down, and then identifying some of those variations in between there, you can start to pick out which areas are a much higher priority, say for shading to increase, like maybe it's got some shade, but by adding more, we could really address this borderline temperature piece like at Oak Creek. And then also largewood and habitat, you can see where it's like, oh, this could really be, like the missing component that could really add a lot to address temperature. So there's many different parts of data that influence there. And so I just encourage you to think a little bit wider and where you can have the biggest influence. So with that, I'm wrapping up my cannabis research. So we've got a little bit for questions. So what do you think? Does this resonate? Does this seem like things that you're seeing, or is it different? Yes, Olivia.
Under the line, we're focusing so heavily on vegetative shade. Are there things that help connect hyperreal flow that are being underutilized in water quality?
Yes. Short answer. There's a lot of components to that. I think we tend to kind of simplify things and then look for just the areas that have very little shade whatsoever. And I would say go a little bit further in that, and don't just look at whether it has shade or not, but look at what the temperatures are saying, and then see where all of these missing components, that in some cases it may make more sense to diversify a riparian zone that has some overhead shade, for example, but needs more of the others, or vice versa. And so I think diversity is a better focus in a lot of cases. At least that's what our data was showing. And there's a lot of things. So I preaching to the choir here, but one of the things I see is there's a lot of places that there's a big buffer. I mean, so at OSU, I'll complain about ourselves because I'm not hurting anybody's feelings, I think. But they've set aside a really big buffer along a lot of their stream zones, but there hasn't been as much active management. So you see, if you're not out there doing something, then it's blackberries and reed canary grass and things that are not providing as much as what could be. So there, and then the hyperreal flow, I think we say that oftentimes when we're not really, it's kind of an assumption. Of course there is, but in cases where you're out there and doing stream temperature monitoring, you get an idea of the depth of gravel that is migratory, that moves. And so some areas you can really see that there's a lot of interflow, and having large woods, something that holds onto that as opposed to moving, you can see the difference in those places. And so yeah, I don't know. I think a lot of that just comes from being in the stream. Yeah. Yes. Hey.
How might access affect that? People pay have.
So a lot of work. Thank you, but I don't. I see that in the watershed councils and groups, when they're doing monitoring, they're putting out a lot of effort. And so I didn't see this as being a great amount of additional effort. It was just a little more focused, I think. So rather, we made the conscious decision up front to focus along main stem and the tributaries coming in, as opposed to scattered, which is a more typical type of thing. So I wouldn't say that, but I'm a big believer in the temperature data logger. It's just a snapshot, right? So it's what is happening that represents what flowed past that point within the last 24 hours or 12 hours, depending on how you're looking at it. And that tells you so little. So you have to, that's just one component. That's like your check, the basic. But then you need to be walking upstream and obviously some downstream, but upstream and doing more of some type of survey, looking at structures and identifying. There's so much that you can learn from observation, but then also actually doing some measurements and then comparing that to see what correlates, what is correlated with this reach that's cooling. That really helped us learn quite a bit. Yeah, and then some places are just, pretty simple, as in this is exposed. Not much you can do there. So, yeah. So access, I mean, yeah, we benefited from OSU, but I don't know, it's it's good and bad with that. So we didn't walk the whole stream. But we did benefit from more public access for sure. On the ranch, though, I mean, that's all private. And we just got hooked up with a guy at the time. The rancher was really interested in the study and what we can learn from it. The unfortunate thing is that he's the manager, not the owner. And the owner then went through a period of change where they shifted their approach. Then they're out of town. So they're an investor, I would say. And so they switched up what they were doing and essentially went to a more of a minimalist type of ranching operation. And so we were kind of let down. So we ended up studying some conditions that it's not like we're promoting some of those management practices. But we did have access when it wasn't snowing. But so yeah, so good and bad. But there wasn't that many cooperators that we had to work with, just a few private in there. Yeah. Yeah.
The variables that you measured was, your diversifying and measuring a few things that are big to measure. Was there like a few that kind of stuck out for you that like seemed to be really valuable and that gives consideration than others?
Yeah, Doug, well, all of them were great. That's the problem of being a bit of a data junkie is I don't know what I would get rid of. But so one thing is that there's a lot of data that you can gather that I think it looks harder than it really is. So I was just kind of going back to that first sheet. So this one. So there's like a lot of things going on, but I don't think okay, so I would say any type of so wetted width and depth. So the more you can understand about that low flow period, that's key because a lot of the other monitoring is based on bank full widths and active channels, and so forth, which is great. But what really matters is the summer when those temperatures are highest. That's what we're studying. And so you need to understand those conditions. And so with that in mind, you're trying to hit those base flow periods and doing wetted widths and depths and, doing this up several hundred meters or so to see your area of influence that's happening to that logger. So you have the logger, then you're going upstream to try to get that reach that's flowing past the logger over your 12-hour time period. So wetted width and depth, looking at the amount of pools versus riffles, because that's the shallow and deep components. The other part of, if you think of shade or cover, I like to say like cover. If you think of all of the components that go into cover, then that's not too difficult to add on. So you're looking at bank heights and essentially some kind of estimate of what's happening along the riparian zone that's influencing that. So those are key. And then the flow, of course, is fantastic. And I don't think that you need as much flow data as you might think. So it doesn't have to be like these with flumes and full on all of that stuff, but it is important to have some idea so what was the flow and low flow period during this year? And a few more times, at least that gives you some range, or we're talking 1 CFS, half CFS, 2 CFS. I mean, those are big changes when it comes to influence on temperature. So yeah, so. Olivia, all right, I'm gonna go to these folks just for a second. Brady, do you want to go? Yeah.
Um, uh, bunch of big, right, of size, channels, channels.
Yeah, I know, right? That's counterintuitive.
That's
So I'm just making a guess here because we don't have it's really hard to determine all of that based on data. So I just kind of simplify and say it's a factor. Whether one is more than the other, I think. So just based on you have the bank heights, but that's the lower part of that sun angle. And so while it's important, I mean, just like in this example, so this is further down, so this isn't even that small, right? So even the smaller ones would be big. So you can see how some of that cover is important and that adds up. But going through any kind of mixing with groundwater, that's kind of like money in the bank. So it's just like anytime you can do that, and then plus what it takes to do that is you're also getting deeper. So you're just getting so much more variety of temperatures. And so, yeah, I would take that over the bank. It's kind of a bonus, but with time for one more? No? Oh, 2 minutes. Oh, great. Lots of time. Yeah.
Information from like groundwater sport context. I know USGS is doing a bunch of work out in Eastern Oregon. I know they did a lot in Harding County. Did they do any in Malheur County that you could pull from?
We were further up in the watershed to where we didn't really have more information. Looking at Carlos, see if he had any information that we didn't. So our studies are more looking at that shallow groundwater, the upper 20 feet or so, depending on what we can get to. Essentially anything that could be connected to the stream. And so I don't think we had really any good groundwater data to help us. Now that's not true in Oak Creek, so that's easier. So in Oak Creek, we did have a lot more information from Wells and a student, Jesse, that was there before me, and then also Todd Jarvis with his knowledge of groundwater, looking at the upper Oak Creek and then the lower part. So he really helped us identify this zone where you have a change or transition. It's basically a fault line. So you have this transition from one dominant geology to the other, and then what that means in terms of groundwater and components there. So yeah, Oak Creek had helped out and helped get a nice paper that Carlos and Jesse Hall had put together. I think that was another question of maybe the person right next to Carlos there, or yeah, any of you over there in that range, go ahead. No, it's just go ahead. That's Caesar, yeah. So there are specific methods of measuring it. So it depends. So there are so other approaches that are very common is using more of a physics-based approach to measuring collecting data of these various components and measuring their impact on the temperature. And so I can't regurgitate all the methods, but there are some specifics of essentially you're digging down and getting an idea of that amount of substrate above the bedrock. And so there are approaches that you could be more rigid and use some of what's been learned in the past in research and have that inform a model. On this one, I didn't go to that depth because that wasn't the focus, but we use these 30-inch rebar stakes for pounding into the stream bed, and we would attach the data logger on it. And then we had data, see, I didn't show, we had data throughout the winter. And so that was really difficult, by the way. So we saw so many changes And so I got familiar with which streams had a huge amount of gravel, and I would come back and be trying to find where the rebar is, or maybe it got kicked way down the stream, and then others that not. And especially when you come in and you're pounding and it's like going in, so I guess I'm saying is experience of working within those. It doesn't take too much to figure out depth and so forth. And then it's a matter of how much matching your data with that. So just a plug for having a digital thermometer that you take out as well. So you have a data logger, but then you take time to measure other components of your reach to see if there's any variation and see where you might have cool spots and warm spots and things. So it's a matter of kind of putting a bunch of things together to get an idea of whether it's influential or not. So I think we're cutting off here. Yeah. Thanks. Appreciate it.